All right, good afternoon, everyone. Thanks for joining us again for another YRP Bitesize session. For those who don't know, I'm Elliot Jordan, Northeast Vice Chair. Today we've got Lorena Muscai talking about civil engineering. So I'll hand over straight to you, Lorena.
Hiya. So I'm Lorena. Thank you for joining and to hear me talk about civil engineering and what I've been doing in the last couple of years since I left uni. So if you're curious about my accent, I'll change the presentation. I'm Romanian. I came to UK to study civil engineering at Newcastle Uni, and I enjoyed it so much I stayed for another year to do an MSc in hydrology, which is just a slightly fancy way of saying I specialize in the water side. And after graduating, I joined the Network Rail graduate scheme. And while being around the railway, I came across young rail professionals, went to a few events, found it really interesting, and I thought, oh, I would like to get more involved today. So at the moment, I'm the secretary of the Northeast Committee. So what have I been up to on the graduate scheme? So this is just some of my highlights. I've done quite a few placements around the company, quite a few 1 week long. Highlights wise, I did a train ride of the new measurement train, and I got to set up the path for trains using the very, very old lever frames. I got to play with the signaling simulator, and I got quite annoyed that I couldn't get two trains to crash. But it was really good to know that there's all that safety net built in. So if the signal is a bit tired or might make a small mistake, that it's not going to end up catastrophically. I've done some track gauging. I thought I'm gonna absolutely hate being on track at the mercy of the weather, but actually I ended up really, really enjoying it. I was part of the committee organizing the graduate engineering meeting. And the reason why I'm pointing out all this random stuff that I did is that although they're not civil engineering related, the railway is so big and so diverse that you can end up doing loads of random bits and bobs. And also it just increased my general understanding about how the railway works and how everything fits in together as a system. And you're working on a small little project, say on a bridge, but actually you have truck going over, you might have SNC, you have loads of other systems and other disciplines you're interacting with, and you need to be aware of them and have a good understanding about what they're doing. So whatever you're doing, you're not messing up with their stuff. And also that, I did a 6 month placement in asset management and 6 months in design. So I got a bit of experience in those. So after a year and a half, I left the grad scheme. So that's literally just before pandemic started, and joined and became an assistant asset engineer permanently. And I went back to the structures route asset management department. Due to the whole reorganization dynamic goes at the minute, there might be some slightly changes in title. So if this is not true in a few months' time, sorry about that. It is true at the moment. And we basically do what we say on the team. We manage the structures. By structures, we mean bridges, culverts, retaining walls, and tunnels. That's not to say there aren't other civil departments on the railway. This is just where I'm at the moment. But there is geotechnics, which look over embankments and cuttings. There's drainage, and there's a lot of train stations and buildings to manage. So there are other areas if you have other interests. So what do we do? What's our main purpose? We're trying to make sure that the structures are safe to use and fit for purpose. It's so easy and straightforward, but when you actually get to the bits and bobs of every day, it gets more complicated. Me and my team particularly, we're looking at bridge assessment, which is basically the capacity of the structure. Is it strong enough to take the passengers in the freight trains? And if it's yes, then great, keep doing what you're doing. But if it's not, then well, what will you do about it? What will you do to make it safe and make sure everything goes smoothly? However, I'm not going to go too much into the assessment itself. It's essentially loads and loads of calculations governed by standards and experience, based on experience, and it just looks at how strong structure is. So I'm just going to go a bit more into asset management. The bridge you see in the picture is, we call it SPD 345 Alpha. The reason why I picked up this bridge is because I was adding it to our databases this week, just to make sure we are managing it properly. We were doing it beforehand, don't worry. We have a lot of level crossings on the railway, and that's where you get the public interacting with the running trains. So it's quite a high risk environment to be in. And generally, in the last few years, there's been a lot of programs to try and close them and just make it safer. However, we can't just close a level crossing because we are cutting access to some people. So a lot of times when they're building bridges, the bridges to make sure we replace them and that people can still safely cross the valley. And this bridge is basically an example of that. So basically, if you're a civil engineer, you can potentially get involved in actually designing this bridge. If you don't feel like that's for you, you can potentially be the project engineer that ends up checking all the design, making sure it's up to standards, that it's safe to use, that you can implement it essentially, or you can be on site while it gets built. But it's already built, it's there. This is an image from Google Maps. You can actually go and see it down in Lenkel. I'm not particularly sure why you would want to go there unless you have other business to see, but it's a nice bridge and it looks like a spiky tortoise to me. So it's been passed on to my department and we are gonna inspect it periodically to make sure it does what it has to do. We have someone going to have a look at it every year. That's usually just a visual inspection. So someone will go there from a position of safety, have a look at it. Basically, is my bridge still there? Is there any obvious defects that appeared since the previous year? And if we have known defects on it, then they will try to see from the position of safety if they can actually spot it and comment on it, like, is it the same as last year or did it get worse and do we need to do something about it? And although that's really useful, it doesn't give us that much information. So usually around every 6 years, we get a more detailed one. So someone will go there and basically tap with the hammer the whole bridge and try and see if there's any loose material, any hollow sounding brickwork. It literally depends on the bridge, but we do look into it more details. And then that's usually where more defects tend to emerge. And if we have defect, it's a case of what do we want to do about it? Is it posing a safety risk? Is it posing a reputational risk? Do we need to do anything about it? Does it affect the structural capability of the bridge? Because a lot of times it might just not do anything. It might just be a bit of vegetation on the side, or it might be a couple of fractures that they're there, we know they're there, but they don't really pose any safety risk. So we don't necessarily need to do something about them in the immediate future. So we can potentially do that later. We can risk assess it and prioritize other works that are more urgent. This bridge is designed for after Eurocodes, so that would mean that in theory it would have a design life of around 120 years. As per current standard, halfway through the design life, so in this case in around 60 years, we would have to assess it numerically. So run some models, run some actual calculations, and see how strong the bridge really is. For this one, it's a footbridge, so we would look if it can take 5 kilonewtons of loading. And then afterwards, we would have to examine it roughly around every 18 years, just to make sure it keeps its capacity. However, those times can actually vary based on how literally its own condition. If it's a poor condition, we would examine it more often, we would assess it more often. If it's in good condition, then we don't really need to do it that often and we can focus on something else. And based on all our findings and its actual condition, we will potentially instruct a renewal or refurbishment to try and bring the capacity up. Or, if needed, a whole reconstruction. Well, this is a brand new bridge, so if you're doing this reconstruction, it's gonna be a while. Probably I'm not gonna be working, I'll be retired somewhere, hopefully. So that's a bit of the asset life cycle and how we manage the bridges. Next, I am part of the Institute of Civil Engineers. If you are an engineer, you've probably been told all throughout uni that you need to get chartered and that is the goal. And you graduate, you go into the industry, and it's still the goal and it doesn't go away, by the way. And there are kind of different ways to achieve that. You can potentially just apply straight for chartership, so that's between 4 and 6 years. Or if you're me, you're gonna try and break it down into smaller stages. I see it as a big scary monster that I'm not 100% sure how to tackle. So I just broke down into engineering technician, integrated engineer, and chartered engineer. I'm just gonna go up one step at a time. And so while I was in the grad scheme, after 6 months of work experience, I applied for Eng Tech. Um, it it doesn't mean that much as far as it goes, but it's one step in the right direction. You don't need a degree for it, and the application was pretty straightforward. It only had 5 questions, 3 technical and 2 soft skills orientated. So that's more team working, communication, code of conduct, and then you go for an interview. And if you pass, you get the extra qualifications and recognition, and you get the letters at the end of the name. It's also recognized by the engineering council, so it's quite a nice. It felt like quite a nice thing to achieve by the end of the grad scheme. And for my next steps, I'm trying to take off attributes for integrated engineer, and basically just breaking it down and getting there slowly. And that's all for me, really. Do you have any questions? Sorry, I'm aware I'm talking a bit fast.
Oh, thanks for that, Lorena. That was really interesting. I'm quite surprised about how long the actual bridges can last for. 120 years is definitely
Can I just point out
way past our lifetimes, I think.
we got viaducts on on our actual path that are over 150 years old. And if you ask anyone how long, when is this gonna be replaced, we're like, we don't know. We need to keep it going for as long as we can. So the massive.
I think it's a testament to. And I was just going to say, I think it's a testament to how good the engineers and designers are to keep it going for that long. But we've got a few questions if you're ready to answer them. So first one is, what is your favorite part about your job?
I think one of the favorite part is the fact that I feel like I can directly influence what's going to happen with the structure, or actually get involved in the afterlives and say what's going to happen. So I feel like I have direct impact, like, oh, the bridge is poor, okay, we need to put the renewal in. So I feel like whatever I'm doing is impacting somewhere down the way. I can see the change happening. And then I can potentially see the benefits that, it can improve reliability, it will improve safety on the railway. So I can see the benefits of doing my work.
Oh yeah, I've got to totally agree with you as a fellow engineer that it's always seeing the end product's always a bonus and how you get there. So yeah. Another question: what was it about the NetRail grad scheme that attracted you to it?
In all honesty, it was the first ones to offer me a job, and I took it. So it just kind of happened. I didn't plan to be on the railway. I'm not a train spotter. I just applied to loads of jobs. It was the first one that I got it. And as I keep doing my research, I realized that it's a really good company to work for, and I'm really happy with my decision. There was a bit of luck, to be fair.
Sort of a sort of similar question that sort of tag onto it, but did you feel that it was competitive to get onto the graduate scheme? Sort of how did that go for you?
It was very competitive, to be fair. I actually applied for it twice. I applied, so I applied to it in my third year while doing my BEng, and I went through the whole process. I got to the assessment center, and I got on the waiting list. I didn't get the job, and I was like, okay, that's fair enough. I couldn't find the job. I'll just go back and do a master's, which I did, and just reapplied and just got the job the second time. So I do think it's quite competitive, and it also depends on how you're feeling on the day and how prepared you are. And we all come up with the same technical knowledge after uni. It's not necessarily about showing that you have that much, about showing what you can do and applying. everything and having the right behaviors for the company.
Yeah, I know for experience that any sort of graduate scheme is very competitive. The amount of people who apply for the limited amount of jobs, so yeah, it's a testament that getting through them is always good thing. You mentioned sort of on your talk about the bridge and sort of level crossings and that sort of thing. Do you get much involvement with multidisciplinary or interaction with other disciplines for your role?
Occasionally, yes. One of the things we get is structure reviews for track renewals. So if they're going to renew any piece of track somewhere on the route and it interacts with a structure, we would get a form that basically reviews how that might influence it. So say you have, we want to lift the track up to 50 mil or lower it or slow it, or we want to use a DTS on your bridge. The question comes, is your bridge strong enough to take it? Sometimes the answer is no, this is a weak bridge. You can't do a DTS on it because you're going to knock it down. So there is a bit of interaction in there.
Oh, that's good. So in your sort of presentation, you sort of described the bridge over the level crosses like a spiky hedgehog. The question is, when you're designing a bridge, do you look into a lot of the aesthetics much, or is it more about functionality over how pretty it looks?
I never designed a bridge. Whoever designed that, it's probably an architect because I don't see an engineer designing that. I would say that usually architects tend to be a bit more on the, does this look pretty? Is it nice to look at? And then you have the engineer coming on the back and saying, right, well, let's see if we can build this and it stand up. And if it doesn't, we have to twitch it a bit because we want this to stand, not just look pretty. So I think from my experience in design, it's quite a lot of collaborative between let's try and make this pretty and let's try and make this stand.
Oh, sounds interesting. So another question is, obviously you're a member of the ICE and you did a degree in civil engineering. From what you've done so far, are the skills transferable, and would you consider leaving the railway?
I'm slightly confused because I'm still working on the civil engineering side. So I know I don't do design, doesn't seem that technically involved, but you do need all the engineering knowledge and judgment to make the right decision and understand what's going on. Because if you don't understand how a bridge works, then how are you going to manage? Someone comes to you, oh, there's a fracture here, and you can look at it and, absolutely panic. And actually, that might not be anything, nothing to be of concern of. It might be in a random place that doesn't really affect capacity. So I do feel like I'm using my degree by having that knowledge, even though it doesn't seem that directly applied.
Yeah. Another question: how often did you go out on site?
Not as often as I would like to. I do have to go at least a few times a year, but due to COVID, at the moment, I'm not really having any plans. But I feel like generally it's a case of you can go as much as you want, within reason. We are encouraged to go out there and see what's going on, see the work getting done. But yeah, I'm more office based.
Yeah, I sort of think that if you're in any sort of engineering realm, you need to get out on site a few times and understand how it works in the real world and what the sort of different practices are. It can be quite valuable in your understanding, your knowledge working as an engineer in the design office. So I think we've got our final question here from the audience. I think it's the question sort of about, are there sort of like year in industry placements within Network Rail?
There are. I know people who've done them, even in my department. I believe there's a whole application process you have to go to. So if you do check the website, it's probably there somewhere.
I know, that's really good. I think we've sort of run out of our questions. So thank you again, Lorena, for taking the time out to deliver this interesting talk on the civil engineering. It's been really interesting. So next, we got another YRP Bitesize next Tuesday at 12:30 on strategic planning. That's something I don't know anything about, so that'll be really interesting to see how that happens. If it is your first time attending one of our YRP events, Don't forget to sign up on the YRP website. It's free, and then you'll be able to find out when other similar events like this are happening. So thanks again, Lorena, and I'll see everyone again next time.
Thank you.